Okay, explain why that can't happen. Anyone? Well, you have a third power radical and a second power root. So you can say that the radical and exponent have different powers. And will not cancel out, and cannot cancel out. There you go. Easy peasy. Questions? Next problem. It's a kind of a dual problem. Here we have two radical problems. How can we work both of these out? Well, you can break them up. First, that's what I like to do. I break them up into their own separate parts. 16 x squared y squared. Alright. Next, I'm going to convert the 16 into its exponential form, which is what? 4 to the second power. And then I'm going to go ahead and cancel out every single radical and exponent that are the same power. Now remember, I didn't write the power of 2 here, but every radical with no power written is automatically second power. So gone, gone, gone. So what am I left with? I'm left with 4xy. 4xy. Simple enough. Over here, same thing. Break them up just to make it easier. And in these problems, you have to show me some work, so this could be an easy work step that you can do. Now 49, I'm going to put it in its exponential form. What is the exponential form of 49? 7 squared, 7 times 7. Next, I'm going to cancel out all of my radicals with their equivalent power exponents. So they're both second power here. And what am I left with? 7Wm. Alright, questions? Alright, moving on to the next problem here. You're asked to estimate the possible root answer. Now neither 30 or 91 are perfect squares. So what we do is we find estimates or two roots between which these two lie. So what are the two perfect squares between which 30 lies? So the smaller and the greater for 30. Well, 30 is right in between 25 and 36. And what are the root answers for 25 and 36? For 25 it's 5. For 36 is 6. So in this case, what is my estimated answer for the root of 30? 5.6, right in between the two. Same thing for the 91. 91 is not a perfect square, but what are some perfect squares between which 91 falls between? On the lower scale we have 81. On the higher scale we have 100. And what are the root answers for each of these? For 81 it's 9. For 100 it's 10. And then of course, what is our estimate for 91? 9.5. And that's a pretty decent estimate here. Alright, next up, we have a Pythagorean theorem problem here. So, what is that Pythagorean theorem? A squared plus b squared equals to c squared. Now, which one's missing here? Which side, which letter is missing? C. And how can you tell? Easily. The longest side is always in front of the right angle. Right angle is the biggest angle in a right triangle, and the longest side is going to be in front of the biggest angle. It's going to make sense. Biggest angle, biggest side. So that's missing, that's C. Shortest side is going to be A, middle side is going to be B. These two, doesn't really matter, you can switch them around, but I just like to write A as the shortest, B as the second shortest. So I'm going to substitute now. 6 squared plus 7 squared is going to be c squared. What's 6 squared? And what is 7 squared? And all of those have to equal out to c squared. Now what is 36 plus 49? If you said 85, I totally agree with you. Now, unfortunately, 85 is not a perfect square. It just isn't. So, what can I do next? Next, I'm going to estimate. I'm going to try to find the root of 85, even though it is not a perfect square itself. So, C is the, let me find, because I always use purple for this. Yay, purple. Root of, which looks just like my blue. That's unfortunate. 85. Now, what are the two the two perfect squares that 85 is in between? (64) and 81. And 64 is 8, or the root of 64 is 8. The root of 81 is 9. So if 85 is in between 64 and 81, the root of 85 is going to be between those two, which is 8.5. So if you got 8.5, you did it. Great job. And I mean, it's a little closer to the 81, so it's more like 8.6 or 8.7, but close enough. And if you wanted to see the work on how we did that, again, I would highly suggest you go back and look at some of our estimating root problems, kind of like this one that we worked on right here. I just don't want to do the work here to estimate my root. Alright, so this is the video for the study guide for trimester number 3. So let's get through it one problem at a time. There are 14 problems on each of your study guides, depending on which period you're in. The first one here, we have a ratio, and you're told to find 4 equivalent ratios to the one you're given. And there are many ways to go about this, and I didn't make this one especially easy because I figure if you practice with the difficult problems, you'll have an easier time with something easier on the quiz. Now you could have either divided, multiplied both sides by 3, divided, multiplied both sides by 2. Lots of ways to go here. Let's say I'm going to go ahead and divide both sides by 3 and multiply both sides by 3 as well. So first let's go ahead and divide on the left side. 9 divided by 3 is 3. 15 divided by 3 is 5. Here it becomes a little tougher. Why? Well, because my next step is to divide both of these by 3 again. 3 divided by 3 is 1. 5 divided by 3, on the other hand, that's not going to work out evenly for you. you're going to get a decimal. And obviously not as pretty or not as comfortable to work with as whole numbers, but it's okay. Decimals shouldn't scare you. So what is 5 divided by 3? Well, if you chose to go with my root, you would have 1.7 or 1.6 depending, how you round it. You could have also divided both top and bottom by 2. That would have worked. Or 1.5, or something else. This is just one way to go about it. Then if I go in the opposite direction, again, I'm going to multiply by 3 both sides, top and bottom. Here I'm going to get 27 over 45. And then next, I'm going to get 81 over, and what's 45 times 3, anyone? And again, if you went with my method, it's 135. And again, you could have chosen something else. And as long as you have 4 equivalent ratios, yours could be as different from mine as possible. Any questions? Next, you're asked a question. Are these equivalent? Well, to find out, what can you do? Simplify them both, and then see what their simplest forms look like. So with 12, I have 2 times 2 times 3. That's 4 times 3. With 18, I have 2 times 3 times 3. That's 2 times 9. 16 is 2 times 2 times 2 times 2. 24, it's 2 times 2 times 2 times 3. Oof, that was a lot of breaking down. Cancel time now, though. This and this, this and this. Over here, these go, and I'm left with 2 over 3, 2 over 3. Indeed equivalent, because their simplest forms are identical. Even though they look a little different from, the initial observation. Questions? Next problem. How can you tell if 2 ratios are equivalent or not? Well, we kind of just did it. But essentially, you simplify them, you put them in their simplest forms. So simplify both, compare simplest forms. It's exactly what we did here. We simplified them both. This one simplified down to 2 over 3, this one too. Again, 2 over 3, we compared them. 2 over 3 is indeed 2 over 3. That's that. Questions about that one? Alright. Next question. We have a word problem here, and it says that Lacey can peel 26 oranges in 4 minutes. Adam can do 28 oranges in 6 minutes. Who is faster? So how would I set this up? Well, let's start with writing 2 ratios. First, the ratio for Lacey, which is 26 oranges in 4 minutes. And then we write the ratio for Adam. And for him, it's 28 oranges in 6 minutes. Alright. So what's 26 divided by 4, and what is 28 divided by 6? Anyone? Well, 26 divided by 4, if you did it through long division, is 6.5, in this case oranges, per minute. And if you were to do long division on 28 divided by 6, you would get 4.67, 4.7, depending on how you round this. Let's just round this to 4.7 oranges per minute. Now, can someone tell me which one of these two is the quicker? Lacey is the quicker one. She can do 6.5 oranges in a minute. The lower number here is worse because that means Adam can do less oranges in a minute. So in this case, Lacey is the definitive winner. She can do more oranges in a minute. So if you needed some oranges peeled, you grab Lacey, leave Adam alone. Questions? Alright, next up we have, why are 6 to 9 and 20 to 3 equivalent? Can someone tell me that? Why are these two ratios equivalent? Because if you simplify them down, they're both the same thing. So when simplified, they are identical. And of course you have to prove this to me. So 6 over 9 I can write as, well, 6 is 2 times 3, 9 is 3 times 3, and 20 I can write as 2 times 10, 30 I can write as 3 times 10. And you can probably see here what's going to happen next. If I cross out 3, 3, 10, 10, I'm left with 2 over 3 here, 2 over 3 here, and of course, well, it's identical. That's how I can tell that they're equivalent. Simplify them, compare the simplest ratios, done. Alright, next. It says, are those two a proportion? How can we find that out? Well, if you said cross multiply them, I would very much agree with you. Very much. Totally. Alright, so yay, good. Now we have them cross multiplied. Let's go ahead and write our cross product. So our cross products in this case are 11 and 15. And I made a mistake. 11 and 18. And 15 and 14. That looks about right. So top left, bottom right, bottom left, top right. Yep. So what is 11 times 8 and what is 15 times 14? Sorry, 11 times 18. Well, 11 times 18 is 198. And 15 times 14 gives us a cool 210. Well, those are pretty close. But are they the same? They're not. Not proportional. So those two ratios are not equivalent, they're not in proportion. Questions about that? Alright, next up, let's see here. We have this problem here on the bottom left. You're asked to solve the proportion. What would you do? What would you do? Same thing that you did before. Cross multiply it. And then the rest is simple. The rest is cake. So my two cross products are in, I think I made a mistake here. Hold on. Yeah, I don't know how that W snuck up there for the near to 36. So the cross products are 36 times 4 equals to 16 times W. So what is 36 times 4? Anyone? $144. And my next step is to divide both sides by 16. So how many times does 16 go into 144? It actually comes out evenly. That's a nice one for a change. No decimals, it's 9. So that is W. That is my answer. Questions on that one? Next one's really easy. You're given a proportion, but the second part of the ratio is missing. And they're asking you, what can you place right there that would make that work? What can you do? Well, literally, you can have so many answers here. You can have hundreds of different answers here, and they would all be correct. What I would do is I would find the simplest way to get an equivalent ratio to 15 over 20 that's not 15 over 20 itself. So don't write the same ratio. Technically, yes, that works, but you're just copying. So don't copy. One thing you can do is reduce this. And I can reduce this easily by dividing both sides by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. So 3 over 4 would work. I can also increase this. I can double both top and bottom. 15 times 2 is 30. 20 times 2 is 40. So I can write 30 over 40. So again, I can do so much here that would work. I mean, you can go into decimals, divide both sides by 2, 7.5 over 10. That would work. So again, I'm going to go with the simplest one, 3 over 4. And I do that by dividing both top and bottom by 5. But again, so many things would work here. It's kind of up to you what to write here. Questions? Okay, this problem says, what does it mean if the cross products are not equal? Ooh. Anyone? Well, it means that there is no proportion. So the two ratios are not proportional and also not equivalent. Are not proportional to no and not equivalent. If you gave me either one of these on the quiz, I would give you full credit. But I'm just writing both so you know. All right. Last one here. Here we have a problem where we have a bag of M&Ms. We're starting with 5 red and 6 yellow M&Ms. We're adding 9 red and 7 yellow. And we're asked if the ratio is maintained. How can we do that? Well, first of all, you write up the initial ratio of 5 red and we have 6 yellow. And we're adding 9 red and 7 yellow. Now some of you just straight up compare it to 9 over 7, which is fine. I like to add the amount I'm given to my original. So I take the 9 and add it to the 5. So 9 plus 5 is 14. And 7 plus 6, that is 13. But if you want to compare it straight to 9 over 7 instead of 14 over 13, that's fine as well. It just makes more sense to me if I'm adding a batch of M&Ms. What does my new bag look like? Well, that's my old bag. That's my new bag. And then I just cross multiply and see if they are still the same. So we have 5 times 13 equals to 6 times 14. So what is 5 times 13 and what is 6 times 14? Well, 5 times 13 is 65. And 6 times 14 is 84. Are those the same? No, they're not. So no, the new bag is not going to have the same ratio or proportion of red to yellow M&Ms as the old one did. If the old one was 5 to 6, the new one is, well, it's not that. It's not that. Questions about that? Thank you.